Well, we had learned from all the data collection on children's deficits that patterns and extending of patterns and some of the math computations were a real issue and a challenge. They were some of the lower scores in the past several years. We used an example of teenagers dancing in dance groups and competitions that's popular for them on TV. And every week there's a new group coming in and they compete against each other, and so that was our hook, to have them watch and analyze the dance routines of some of these dance crews. Children need to be excited about learning, and the one way to get them excited is to have them actively involved. And once they're involved and you've set up a situation where there's a need, the skills, they're readily learned, and they're 21st century skills of higher critical thinking. We wanted our children to be able to recognize a pattern, be able to tell whether it was repeating or growing patterns, tell what the period is for the pattern, like how many numbers or moves or pictures were in the period before it was repeated, and most of all to be able to extend it way past its original parameters, because that's the kind of SOL questions that's asked and that the children are having difficulty with.
This is a guided inquiry lesson. We start out with a testable question. Our essential question is, how does the change in a period affect the pattern? And students collect data from that. They collect data using patterns and graphing and extensions, and they use that data to form conclusions.
I'm adding because these are minutes, 60 seconds are in a minute. That's 6, 12, 18. Plus 30 because it's half a minute. 8, 9, 10, 11.
Some teachers need to have a strong math background. They need to be very familiar with patterns, extension of patterns. They need to be familiar with how to calculate an average, because an average time is calculated on this. They also need to be familiar with graphing, in particular line graphs. They need to understand that line graphs show a change over time.
The students are first watching dance routine. Then they're using a website to program Pillsbury Doughboy with 5 or 6 different moves that they select in any order or combination they want, with it, put music to it, and watch their little doughboy dance virtually online. And once they've done that a few times and understand that that movement can be translated to number patterns, because each movement can relate to one number, they assign it a number, then they create their own dance routine that doesn't have to look anything like Pillsbury Doughboy. And once they've done that, they select music to go with it.
1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4.
Okay, that was 12 seconds. Do you want to add anything else to it, like one more step?
The students have to perform their routine and time it. Not once, but several trials, and then take an average of those trials. So now they have data of an average length of time. And then they have to time their music clip, whichever music, whether it's country or Star Wars or hip hop, whichever they've picked, and get a beginning and ending time and figure out that elapsed time for the music clip, and then reconcile how many repeats they will have to have. And they do that by graphing and predicting, and then they test their predictions. So the data drives the points on the graph, and then they analyze the graph to predict and then monitor and adjust.
So our math, when we did our first trial, we got 1 minute and 12 seconds. When our song is 1 minute 31 seconds long, and that's 91 seconds. So, and then we divided 1 minute 72 seconds by 2, and we got 36. And then since it's 1 minute 31 and 91 seconds, I thought that if we did each dance routine pattern step once for 9 seconds, seconds, and all of the spins will go together, so each spin will be 3 seconds long. That will all equal 9 seconds. So 9 times 10 will equal 90, and then 1 second for the bound.
Well, what's nice in this lesson is it does reach a lot of different levels. You know, the students, depending on how you decide to group them, can make the pattern as difficult or as simple as they need to based on their skill level. So they can, right there, they can differentiate on their patterns. Another thing that they can do is for your challenge group, when you're talking about extending patterns, you know, for your different levels of learners, you could structure that question of, you know, well, what's, you know, the next pattern in it, or what's a couple above. But for challenge, for super challenge, you could say, well, what's the 100th pattern going to be on this? And have them develop a way on their own of how you would get that besides acting out, you know, all 100, you know, repeats of the pattern.
All the features of STEM, science, technology, engineering, and math are included. The last letter in STEM is math, M for math, and of course, being math-oriented, that is where our focus is. We're including basic computations of all sorts, averaging, which is a huge SOL requirement for 5th grade, and graphing, and timing, because some children, when they use the stopwatch, have to take the start time and the stop time and figure out what the elapsed time is as well.
We did our dance, since it's 30 seconds long and the song is 4 minutes and 7 seconds long. We divided it. It would be like, if you took 30, it goes into 1 minute twice. So it would be 8 for our thing, and we'd have 7 seconds to spare.
This lesson, although it's geared towards math, does have a lot of investigation involved in it, and it tends towards the investigation of patterns in nature, which is, you know, huge in science, is investigating those patterns in nature for science. So it lends to support the science in that sense.
Technology is used repeatedly for getting music offline, watching video clips online, and recording themselves online. Children now know how to extend the pattern. It was a discovery process for them. We called it jump-ins, and they realized that instead of sitting there and counting every number in their pattern, and if the pattern was 7 long and they had to figure out what jump-in 23 was, rather than sit there and count, they realized they could do multiples, and it was a division, and it became very easy, and it was like you could almost see that light bulb going on. And we did quick checks with paddles, little whiteboard paddles, so they'd show them all at the same time, and we had 100% at the end. Repeated 100%, not just one chance at it. So they realized, and we were doing things like 7 movements in a pattern up to 102, 72, 75, and it was like that. It was, once they got it, they understood it. And on the benchmarks in our area, when they had to do extending of patterns, it was not a problem for them at all.
Pattern 4 times. How many dance moves would you have?
Assessment results from the pre to post test showed improvement, which would definitely show that the kids are gaining some understanding of what we hope that they learned from the lesson.